Hello everyone, my name is Namdi. Welcome back to OBINexus. What is OBINexus? A design and technology company from the heart. Okay. So today I want to speak about a new tool called NLink. NLink is a Nexus linker. It's an implementation. It's my implementation of a Nexus linker. Why would you use first of all, it's a Nexus linker. It's a linking tool. You can link any project to it. It's not really a direct implementation of a polyglot system, but it's just a linking tool. You don't need to link all the artifacts. It's for compiled languages only. That's like C, Rust, or Python. If you're using Python or the C implementation of Python. Or COBOL, or it just allows you to link artifacts that are compiled, not interpreted. Not like interpreter Python or JavaScript or Lua, not scripting languages at that level. NLink is a Nexus linker. That means it links components, one, two, three components in an orchestration system. It doesn't link. It has two types of link. It doesn't link like an LD or the LD.exe or the linker definition, which matches links to object files in traditional sense. Why use nlink? Nlink.exe, which is the proof of concept on github.com/obinexus/mvp, allows you to use the Nexus linker slash nlink to link C projects, which the MVP is written in C. Why C? Because it's not Rust. This is the MVP, so we have some stages to make it perfect. But you use something called SymverX. SymverX is semantic versioning extended by me, Namdi. It allows for components which are what you're meant to link to be swap swapped. That has some features of NLink. The Nexus linker or the nlink.exe allows for uses configurations in three tiers. You got the root manifest. So you have an nlink project. You have to organize them in components, and I'll hopefully show you an example when you go down and when you watch more videos. But say you are linking SDL. The problem you solve with the LD is you have to link each component. LD.exe. Oh, my fingers. Okay, I'm not an AI, but it's like you can't go there. LD.exe links everything. What nlink does is different. It links only what you need. It's a lead by need linker. Link by need. So that's what it is. It only needs what you need. It's a dependency hierarchy. Using MD, only links that's what you need. Whether directly built from the nlink source or using nlink.exe or linked or components using nlink. So you have like an ELF system that recognizes the data, what is data, or what is code, whether it has the driver context, or whether it's built the binding, whether it's just some object library. So if it doesn't mean an exe, that's the executable context and call like some artifact to register the nlink.exe. The nlink ELF system is really about recognizing the kind of components you want to link to. Using something called Nexus search. Now this is all complex, but I hope I give you some examples. Nlink is an indirect linker and direct linker at the same time. So by direct linking, I mean with automatic system memorization, you're linking each component of one system. Like whether you have some internal components only. But indirect linking refers to the concept of introducing libraries like SDL and only linking what is needed. That's what the nlink gives you. That capability to link projects into your own production or to migrate your own library system. It's not polyglot by design, but it uses some principles that are polyglot-like to ensure that your builds remain small. Now let me give you the main problem here. When you have Rust.exe, when you write a hello world program, I believe it's 3.2 gigabytes of data, which is like a bloated binary. Hello world, that's very problematic because that's a hello world program. But developers who use Rust don't know that, don't do that because that's a lot of data for a simple hello world program. if you control it to C or Python, you know, just to print hello to the screen, to the terminal. Now that data, so it goes in bytes, gigabytes, megabytes. So 3.2 gigabytes is like less than megabytes. Mega is 1,000. Giga is 100. So it's a 1,000 bytes. 1,000 bytes. So that's too much. It's not much. So what nlink does is only links all the components. So imagine Rust and exe only linking the articles it needs at runtime, at compile time. You know, that reduces the size of any binary, any library you create. Okay, and that's what nlink aims to solve. Is this something called my breakthrough in the Thomas minimization? You know, there's no trade-off here. It's only links what you need based on the data, everything. You know, the MMD flag you don't have to make file. Which organized dependency hierarchy. Think of it like that. You know, there's something called when you do make -mmd. There's a dependency that generates something called a .d file. And that .d file is the dependency hierarchy. Now we only have a link dependency hierarchy with nlink. You know, we don't want bloated binaries or bloated executables. So we can take any app, bring a linkable LG in C, Python, or game app, you know, and we can write it. We can run this app with with nlink, and nlink will give you the smaller size binary, like, you know, something that's so small, you know, how much is small, you know, it's like even your traditional hello world program will be reduced, you know, by 95% reduction. I don't know. I haven't really benchmarked this. But I believe it's 90% above. You know, it's ridiculously small. Yeah. So what I'm saying to you is that nlink is a Nexus linker. So let me show you how the breakthrough works. So nlink.exe, when you run it to link some alpha, you have something called a pkg.nlink. This is like the pkg.nlink is the root and the root project. So if you're writing some kind of a LZO project, and you link here with, say you're building an ambient noise system for a game, you know, you're creating your own LZO package, you know, ambient noise, you know, an ambient noise library, you know, something that takes inputs from my voice, from this noise, and turn it into background music, separate from the midground, and which one hosts want to try? You're using SDL to do it. What this gives you is you separate the background music, so from the midground and the foreground, you know, so you have some kind of orchestration, like, you know, to when people interact with the environment, some kind of noise you play, you know, but, you know, for a game, you know, what nlink does is it allows you to link only what is needed, and how that works is with this breakthrough. So imagine a traditional trading tester. This is one not nlink. So imagine a traditional tennis tracker. You know, tennis tracking is like when you track the skill of tennis, you know, it's just a program to track tennis. Automatic system machine can solve this problem, you know. So when you have like an optimal program in terms of in traditional computation, you track each state. There's say between two players. So you have like an expert player and a beginner player. So the expert player can always be a professional person. Say there's 2 rounds only, 2 rounds. You know, 2 rounds to the game. You know, 2 matches. So we have like a first round. First match, round 1, only 2 rounds for the end game to be match point. So you go to the professional player, then does from 0-0. The machine starts at 0-0. 0-0, we go 15-0. It's recorded, so the machine goes 15-0. It's recording 2 states at once in parallel. 30-0, 45-0, 1. That's match point, you know, because it goes to 1 or what is called game point, or love in tennis. Love is 0 in tennis, but, you know, it's not really important. So we got 0, 15, 30, 45, 1. Match point is 1. That person to the expertise and that man gives 1 point to the 0, you know. But, you know, so you see you're really angry, you know. I like this energy. You're really angry now. You're not sure why the person beats you, or you're so necessarily say maybe it's the machine. You know, let's say this machine. You know, because I'm trying to get my chances up, and because you are so ambitious, they let you, because it's your final time to win this game. But, you know, this guy is so expert. He's saying, what are you talking about? So what I'm saying to you is my breakthrough looks at the traditional implementation and changes how we track state machines in a bit way. It's a breakthrough. So we have like so we have we'll start at 0, 0. So it's an epsilon state. You can start at epsilon or 0 if you want to start at 0, but I'll give you two implementations. So the object displays 0, 15, nothing. 15, 0, because we start nothing. Say we start nothing. 15 epsilon. Epsilon means nothing. Nothing is being tracked. So when the man goes, so it goes epsilon, meaning empty state. Empty state. The thing has no shift or nil. Nothing has been stored. Nil means no type, no memory, and no value. Nil means there's no type associated with your tennis score. There's no memory allocated for that tennis, and there's no value for that tennis. Unrecorded, basically. That is the nil state. Nil, Rift has this. The Gab Rift is but I'll get back to that. But the nil type is just an epsilon version, empty. It stops a lot of race conditions happening. So we go, you may use epsilon and nil interchangeably, but they mean the same thing. So we go to epsilon, empty solution, or nil. So we go to 0, nil. Nil, nil. 15, nil. So you're still losing. 30, nil. 45, nil. And 1, nil. So you now lose again, and the games, and then it says match point A, game end. Tennis game end. You still lost 2-0. That's how the end. So you see the analysis is like the machine is not tracking anything, or the computer, or the state of the machine. The computer is not tracking any state. It's not storing anything. It's not accumulating information to be marshaled to the end record or the computer. That's the breakthrough, really. It really just doesn't. It's all log n. The compute time is. If you are to track two states in parallel, it's log n because you're tracking two states. It's half the time to track that state. That's log n. But that's space complexity. It's log n to store something on the computer, to send it to the storage space. That is log n. It's not really it's cutting the time linearly in half. And that's what I'm trying to do. So the NLink.exe is tracks. What I want to show you, when we have the MVP complete, we have a lot of stages on the GitHub page on MVPs. We can try to look at them yourself, but they're not really complete. They are complete soon, but because it's meant to be written in Rust, because Rust can track memory. We don't want issues too with Rust. So what I'm saying to you, we got the exe, yep, and we can run. I can show you how it works. But we have to understand the indirect linking concept. Say you have your own component, like something like a library, like a shared object like you make yourself. You link it with the function position independent code, FPIC, and you then make it a standalone library, shared object or .so, which is like a aggressive program two programs can work with it, or .o or .object file, just a standard Unix compliant object file. What you try to do is make sure that the object file is separate from the shell object, so you can use linkers. But NLink allows you to indirectly introduce components to be linked across your project. Because it's a dependency, it's a library that you're using to link it, and that will only link or the DLL file for Windows, the dynamic library that will link across components. That's what NLink gives you. It's so flexible. NLink is this semantic version X. Semantic version in version 1, minor, major pass. How X is extended. It allows for mapping of experimental features, stable features, and legacy features, stable features, and experimental features. In an orchestrated fashion. Because the thing is, what NLink does, it allows you to create devs, develop artifacts, develop a linking process. It allows you to migrate your code into a production, which is why we have that config file. So we got the root pkg.nlink, which is the nlink.exe. That's a configuration system for the whole system for components. Say if I have so that's the root. So if you have a project, you have my SDO project, and you have a component waveform. Waveform. We're gonna only be waveform synthesizer library using nlink.exe to build it. You want to link all of them. So the pkg link is the root. It's the manifest file. You got the pk link. Pk link is the package.nlink file. To link everything. Now we got the nlink.txt file. So we have that too, and we got the shared component, or the so say if you have component one, which is an actual name for a component, like an audio processing system for wave video. So you say, okay, so we say you're building a synthesizer. It's a synthesizer. That means you take electrical signals and process them in a way that's coherent. Which what synthesizer is, or you're making an SDL synthesizer library. You can link it to SDL and use it in an Azure project. That's the idea here. So when you link this project to SDL, what you're trying to do is take that synthesizer, my SDL synthesizer or SDLX, whatever you call it, which is waveform, to convert into electrical signals for the computer to process into some kind of output system. What you try to do is to link that component system into a shared object library or .a file, which is short to archive to link it. Nlink can do two of them. So you can package it to some some A file or some archive, because it's just the standard representation of that system. So if you're using Windows with DLL, if you're using Linux, but it's not really doing that all at once. It's using this compiler you're meant to use, like GCC, TCC, Tiny C compiler, which is a tiny implementation of the GCC. Minimal. What I'm saying to you is, I want to demonstrate the power of nlink. So in this nlink, I'm going to try to demonstrate, and I know the voting is on, so you can, if voting is on, so if you don't read the description, I'm telling you, I'm going to enable voting, and the more people that get voted, the higher the video goes, the more like videos stay on the top, and that's how that's going to work. So on the playlist, that is. So that's the nlink system, working in parallel to achieve something. Yep. And that's what we're going to try to build nlink off. So nlink supports indirect linking and direct linking. SymFX, in the schema, in the packages.nlink. And is a 3-layer configuration system. So we got the first one, nlink.txt, which is for every component you make. Like every directory you have, you got some source and include artifact, and it builds that component, which is the root. So that project has a pkg.nlink for that component. Yes, for that component is a pkg.nlink. That's a package in it. So there's two main components, and we got the is it 3? I don't know. I can't remember. Okay. So we got the pkg for the component and the roots, because it's a package you're building, and you got the shared components. So if you want to expose some components, you can declare that in the pkg.nlink or nlink. So if you have a component one, which is waveform synthesizer, from background more noise to computer processing. If I blow the air or make a random noise, it will change how the waveform behaves and changes the feature of a game. Control it, make it feel. It's meant to control the spikes too. So what we're trying to do is make sure that nlink.txt is a component system. So you got the nlink.txt, which is component bound. So but it's shared. It's like if you have a root nlink.txt, you have to put it in a /nlink folder. Put it on the swap folder, and that will give you the shared artifacts across components. So all the utility library basically. But every nlink / shared component or utility allows you to have must be, if you want to, because you want to use an nlink.txt for that. But it does allow packaging too. Because unless it's local, the local ones, protected public, uses nlink.txt. The protected private uses nlink. But if you want to package it as its own component, you use something called pkg.nlink. It's up to you to decide which one you need. But you can put the nlink directory and register it as a shared component too. So that's the component 1, 2, 3. Organize how the dependency is resolved. Organize how the dependency is resolved. So you got component 1, which is like waveform synthesizer. You can make the waveform more natural using PRNG noise or something like that, manipulator, oscillator. And then you use that to dictate how that flow of that sound will interact with the SDL program. So when you import the library, like you include, or you then link it to your program, your main.exe, you get all that functionality. But your main.exe can use nlink or ld. It doesn't matter. If you want to use the nlink on ld, you just decompose that need. But I prefer you check out the nlink project on github.com/OBINexus. In the next video, I will be showcasing the progress so far with the nlinks projects. But this is OBInexus computing Namdi Michael Akbala signing out. Have a good one, and like, share, and subscribe. And check out the project on github.com/OBInexus, and it's yours to check. You can use it, you can try it out, you can break it if you like. I love that. It gives me something to do. Because I want to make sure people understand what I'm trying to do here. The more you mess with it, the more issues you create on GitHub, the more I will like. The more the computer support grows, the more the community support grows for GitHub. The .com/OBInexus. So OBInexus, again, nlink stands for Nexus Linker. It allows you to, and the MVP is written in C, not Rust. We're gonna write it in Rust. When we're sure we have all the stage bound, we got a lot of folders there trying out new features of hostable logic. Hostable just means you can swap versions out. You can by channel. So we got like a staging. So you can swap versions, and that's I forgot to say. Yes, one more thing I forgot to say. So we got Nexus Search. Nexus Search is it allows you to search packages up. It allows you, and nlink must support that. nlink.exe supports the searching. It uses something called a star scoring algorithm, which is a graph matching that matches the packages in order of complexity at runtime, and stores that, allows you to store a real bit after. It allows you to really update the Nexus Search and the Nexus Link. And Nexus Search is just it's a utility. It allows you to search artifacts, but it's written in JavaScript. It's not written in JavaScript, but it's written as a proof of concept, as an MVP2 for nlink. So the Nexus Search works like this. You have a regular expression. A regular expression using a graph three node structure. So you have characters as a tree. You have characters as the nodes. So you're searching for cat, fat, dot, rats, and you want to search for that. You want to search for that. So the words are cat, dot, rat, mat. So I'm searching for that. I use something called BFS to match, or DF and DFS2, and with A star scoring to match instantly. So if you're looking for with an LIU catches for previously LIU catches and MRU catches to find what you need. So that's what. So what you're doing is so say if I search for dot, I put on D, I get AT, so DART, and now I put an A, I still get cat, fat, mat, because I got AT at the end. Now if I put an R, it will show me dot. The uses BFS transversal, which is like a bottom breadth first search. It allows you to index your tree structure downwards. From the left and right node. It uses something called postfix notation to represent a prefix. Breadth first allows you to index at levels, as node levels, X and Y, on the node branches, on the node leaves. So if I have like a cat, D, if I search from dot, the root one will be D, the A will be R, and if A has R and T, it will match it to A out, and it matches it instantly with A star scoring, because it uses Dijkstra. It doesn't use Dijkstra, it uses A star scoring to match all of them instantly. So what Nexus Search means in here, it allows you to search up modules, search up libraries, and link them using regular expressions. Nlink that you can support, yes, it supports regular expression to find. That's why you have to keep a clear standard to what you do with nlink, which I forgot. Or you can use something called BFS and look up caching, caching things that have been cached. And that's how Nexus search is good. So that's for using server X, semantic version in X, the Nexus nlink.exe, and a configuration 3-layer configuration system to build your own project, your own library, and that's the output. When you build the library, you can get an XML file in case it breaks, and you can build from that manifest file to, because it's fault tolerant too. It's fault tolerant. That means you can recover from a previous state. If the configuration are just, if you really got a build manifest, which is just the in files, the input files, nlink.txt, nlink.pkg.nlink.n. So this reduces all your bloated binaries, all the sizes, all the states, all the libraries, all the files you built into a single source of truth, which you can put in a standard diagram representation: build/bin, lib, and all those shared artifacts. It allows you to do this in a way that is maintainable and evolution. From development to production. Whether your stakeholders are involved and building new features, or removing old one, or fixing a bug in a code, or hotfix. It allows you to patch based on Server X, extended versionable. Also know that Server X allows you to semantic version X allows you to swap a components by version, like major, minor patch. If you have what you want, if you have a dependency, and here's a bug, can stop people using it and rollback changes, or solve it how you meant to do it on the endless schema. Because these are the future of the world. These are tools for the future. So that's what nlink means. Nlink is a Nexus linker. It allows you to link by need, only what you need, and it also resolves the dependency, the daemon dependency issue by giving you the latest version or the previous version, the one you choose, explicitly stating where it's located, where you want to put it. It allows there's a way the clear using the dry principles. It uses so to mitigate the daemon problem, which is dependency relationship, like version 1 or version 2, update dependency. And the system, you have to tune your system. You can find the right one you need based on the Server X system, because it allows you to pick a system, pick one. So you don't resort to a main. So you can have a transversal by linking what you need, which is the problem anyway, which is a sub problem. But I've it's been solved. Okay. Thank you, and good. Thank you and goodbye. Computer from the heart. Thank you, goodbye. Check out the next video. Like, share, subscribe it. It means a lot to me if you go on the GitHub and check it out and give an issue for the C1. But it is functional. Thank you.